All right, and now question 12, right? So in question 12, we are supposed to use the chain rule to compute not just partial derivatives of the function w, but some complicated expression that involves these partial derivatives, right? So let me explain what's going on here. So here we have a w, which is a function of x and y, and in turn, x and y are functions of s and t, right? So w is a function of x and y, where in turn x is a function of s and t, and y is also a function of s and t, right? So it means that hypothetically we could just substitute the expressions um, in s and t for x and y into w, and then w becomes a function of s and t, and then we could just compute this whatever expression that we need. But we are required to use the chain rule instead, which I guess, to be honest, I'm not sure what is going to be easier, but let's do the chain rule since it's just required. Okay, so so let me first do the partial derivative of w with respect to s, right? So by the chain rule, this is going to be the partial derivative of w with respect to x times the partial derivative of x with respect to s plus wy times y s. Okay, what is partial derivative of w with respect to x, right? So we've got to differentiate this expression here, and this is going to be just 2xy squared times the partial derivative of x with respect to s. It's here, and it's just 1 over 2 square root s plus wy, which is 2x squared y times ws, right? So we're differentiating, sorry, ys, we're differentiating this guy here, and doing that we will get, I'm sorry, doing that we will get, oops, 2, sorry, not 2, so 2 is in the denominator, so it should be with respect to s, right? So it's got to be square root t divided by 2 square root s. All right, so notice that we are actually supposed to find not just ws on its own, but we've got to multiply by square root s, right? So let me multiply by square root s. Okay, so multiplying by square root s, basically we are going to get rid of this square root s in the denominator, and also 2 is going to cancel out, so whatever remains is just xy squared plus x squared y times square root t. Yeah, so that's the final result. Okay, so now let me do wt in the same fashion. So wt is going to be basically, because of the same chain rule, it's going to be wx times xt plus wy times yt. So notice that wx and wy have been already calculated because we have used them in the first expression, so we don't have to calculate them again. So we can just copy them from here. So 2xy squared, and here 2x squared y. Okay, so now we need to find xt. So now we've got to differentiate this expression with respect to t, and this is going to be 1 over 2 square root t plus, okay, and the derivative of y with respect to t, this is y, so this is going to be square root s divided by 2 square root t, sorry. All right, so and again 2 cancels out, and so notice that we're supposed to find not just the standalone wt, but we've got to multiply it by square root t. So let's do that, times square root t, and times square root t basically eliminates the square root t in the denominator. So the final answer is xy squared plus x square y times square root s. All right. Okay, and now let us look at the difference, right? So what we need to do is we've got to find this expression, square root s ws minus square root t wt, right? So which means this minus this. Well, and of course when you subtract the letter from the former, so xy squared cancels out. So whatever remains is just, so let me write it here. This is the answer. Is x square y square root t minus square root s. Well, and I guess since the final answer is sort of supposed to be a function of s and t, right? So since it is sort of formulated, right? So with s and t, we've got to substitute expressions in s and t for x and y, right? So this is going to be really, my x is square root s plus square root t, so square root s plus square root t squared. Then I have y, so square root of st squared, so it's just st. And then I have this square root t minus square root s. Now, if you want, you can simplify it further. If you don't want, I guess, I'm not sure if this can be simplified even much further. I guess you could rearrange a little bit, probably like, I don't know, square root s plus square root t times st times t minus s. But it's really, it doesn't look much simplified to me. Anyway, so that's how we do this question.